Now, 3 parts. In part one, we'll solve this math problem. In second part, we solve last problem of USACO Silver First Contest, December 2022, and we will consider the ideas that are useful for preparation. USACO 2023, 2024, and so on. And in part 3, I leave a homework. So let's start with part 1. If you want to learn other important ideas, feel free to send message to my WhatsApp number in the description. For this problem, instead of +1, +2, +3, if we consider mid-1, it's the famous changing variable as idea 1. We want to use changing variable. If we consider this one equals y, then x plus 1 is y minus 1, so it will be y minus 1 squared plus y cubed, we can write it like this, plus y plus 1 to the 4, because many terms can be cancelled when you write like this, equals 2. And now for this one, we should know the identity a minus b whole squared, binomial, special case of binomial theorem. A squared minus 2ab plus b squared. So first one is what? Is y squared minus 2y plus 1. Next one is y cubed. Next one is, we should use this one, a plus b to the 4, special case of binomial theorem. And I will tell you, a plus b to the n general form is what? Here it will be a to the 4 plus 4 choose 1, 4a cubed b plus 4 choose 2, which is 6a squared b squared. 6a squared b squared plus 4 choose 3, which is 4ab cubed plus b to the 4. And in general, it is n choose 0 a to the n plus n choose 1 a n minus 1b to n choose n b to the n. Okay, we call it binomial theorem or expansion. Now, y plus 1 to the 4 is what then? Is y to the 4 plus 4y cubed plus 6y squared plus 4y plus 1 equals 2. Okay, so this one, because of this, y cubed, y squared. Now let's simplify as much as we can. Here, 1, 1, and 2, we can cancel them. Y to the 4, we've applied this. For y cubed, 4y cubed plus y cubed. 5y cubed. For y squared plus 6y squared plus 7y squared minus 2y plus 4y plus 2y equals 0. In next step, in this step we can factorize. We can factor from y, it will be y cubed plus 5y squared plus 7y plus 2 equals 0. Now, y first case. First one is 0, y is 0, y is what? Y is x plus 2. So x plus 2 is 0. And if y is 0, we can check. Here 0, 1 to the 4, negative 1 to the 4, it will be 2. It's correct. X plus 2 is 0, so x is negative 2. And you can check, for example, if during exam you reach this, you can quickly check. Make negative 2 here, 0. 1 to the 4, negative 1 squared, 1, 1, 2. So it is our first answer. Now let's consider case 2. Case 2 is this part equal to 0. So we can conclude y cubed plus 5y squared plus 7y plus 2 equal to 0. Idea 5. When the degree is at least 3, one useful way is try to find one root, at least one root. Then you can factorize. Here, if we can find one root, then we can factorize, and the rest will be quadratic equation, and we have quadratic formula. But we should find a root. Idea 6. Rational root theorem or rational zero theorem. Rational root theorem. It says what? It says if we have a polynomial like this, a and x, one way is to check plus minus 1, 0, plus minus 1, plus minus 2. One way you can write like this, if it has a root, and the root is p over q, then p is a factor of a0, and you can prove, as homework you can prove this. Q is a factor of an. So, if you have a root p over q, p is a factor of a0 too, so, and q is a factor of this one, 1. So, factor of 2 can be 2, 1, factor of q is 1, and we can consider plus minus. So, the numbers that we should check. Plus minus 1 for 1 over 1 plus minus 2. Here, if our root, for example, we want to check these ways. If it is positive, this part will be positive left-hand side. So we need to only check negative 1, negative 2. So if y is negative 1, negative 1 cube is negative 1, plus 5y squared is plus 5, minus 7 plus 2. So it will be what? 5 minus 7 minus 2, plus 2, 0, negative 1. It doesn't work. It's not a root. If we replace y with negative 2, negative 2 cubed is negative 8. Plus 5 times negative 2 squared is 5 times 4. Plus 7 times negative 2 is 7 times negative 2, negative 14 plus 2. If we simplify, it is what? Minus 8 plus 20 minus 14 plus 2. 20 minus 14 is 6 plus 2, 8. 8 minus 8 is 0, so it is a root. So y equals negative 2 is another root. And from here we can find related x. Related x is what? Y is x plus 2 from changing variable here. So in this case, x plus 2 is negative 2. So x is negative 4. We found second root. And you can check. Negative 4, it will be negative 2 cubed, negative 8, negative 4. It's negative 1 to the 4 is plus 1, negative 4 plus 1, negative 3 squared, 9. And it will be 9 minus 8 plus 1. It will be what? It will be 2. Okay, we've checked second root. Now let's factorize. We know y cubed plus 5y squared main equation here. Plus 7y plus 2. When y equals 2 is one root, you can say, okay, one factor is y plus 2. Now let's figure out second factor. I want to create y cubed, so I place y squared here. We have y cubed plus 2y squared. But I need to reach 5y squared, so I need 3y squared. So 3y. Then you have 3y squared plus 6y. So this one is okay, this one is okay. Now we have 6y, we need y to reach 7y. So I place 1, it will be y plus 2, and last one is 2. So all of them now are correct. This one is 0. Okay, let's erase this part. Now I've checked this one, y equals negative 2 and x equals negative 4. Let's check this one. For this one, y squared plus 3y plus 1 equal to 0. Identity 7. Quadratic formula. When the degree is 2, there is a quadratic formula. You can factorize if possible. If not, you can use this. If we have ax squared plus bx plus c equal to 0, then x equals negative b plus minus square root of b squared minus 4ac all over 2a. And here we can say, okay, y equals negative 3 plus minus square root of 3 squared minus 4 times 1 times 1 over 2. So it will be negative 3 plus minus root 5 over 2. Now it is y. Y was what? Y was x plus 2. So we can conclude if we subtract 2 from both sides and switch left hand side and right hand side, x equals negative 3 plus minus root 5 over 2 minus 2. And if you use common denominator, it will be negative 3 plus minus root 5 minus 4. And it will be negative 7 plus minus root 5 over 2. So we found two more solutions. So how many answers are there? Negative 2, negative 4, negative 7 plus minus root 5 over 2. We found 4 answers. If you want to learn more ideas like this or want to solve more problems, prepare for any math exam, feel free to send message to my WhatsApp number in the description. Now let's try to solve problem 3 of USACO 2022 December contest, first contest, silver part, problem 3, range reconstruction. So, read the problem first on your own. Pause the video and read it. Okay, the problem says, let me explain the problem in the input outputs. For example, for this input output, let me explain for you. Here it says 3, we have 3 elements. For example, A1, A2, A3. And 0 means range in this part, means maximum minus minimum. A1 minus A1 obviously 0. So that's the reason all of them are 0. For this one, maximum minus minimum between these two numbers equal to 2. For this part, again, maximum of A1, A2, A3 minus minimum of A1, A2, 3 is 2. Now A2, A2, 0, obviously A2, A0, because A2, A2 maximum is A2, minimum is A2, so 0. Between A2, A3 is 1, and A3, A3 again is 0. Now it says it is guaranteed that there is some array A with values in the range 0 to 10 to the 9. But our answer can be from negative each AI that we print as output can be from negative 10 to the 9 to 10 to the 9. So if we use C++, we don't need to use long line. We can solve it with int. And now here. A1, A2, the difference is 2. Let's find an example. I say, okay, the first one, for example, 0, second one is 2. And look here, it says output can be from these numbers. So we can also use negative numbers. 0, 2. Now A2, A2, A3 is 1. So we can use 2 plus 1 minus 1 or 2 plus 1, 3. This one doesn't work because here the range will be 3, but here it says the range is 2. So 0 to 1 works. And if you see, okay, 1, 3, 2, you can shift by anything. The difference won't change. So it is our answer. Now let's solve another one. Here again, if we consider A1, A2, A3, range here is 1. Range here is 1. Range here is 0. So we can say first element is 0 without loss of generality, and second element can be 1 or negative 1. I consider 1. Again, without loss of generality. Next one, because it is 0, it should be 1. And if you see, it satisfies all these conditions. 0, 1, 1, okay, same as our sequence. There is no unique sequence. For example, here we can shift all elements. For this one, let's write again A1, A2, A3, and A4. Let's consider the range. For this one, it is 1. For this one, it is 2. For this one, it is 2. Now here, 1. For this one, it is 1. For this one, it is 1. And for this one, it is 1. Now let me explain also the algorithm is what when I want to create. I say, okay, first one again is 0 without loss of generality because we can shift all elements. This one can be plus minus 1. I consider 1 again by symmetry because we can negate all numbers. A3, it is first you say, okay, it is 1, so the next one is 2, 1 plus this or 1 minus this. 0. Now if I consider the range here is 2, it's okay, the range here is 1, so this one will be bad. Now let's consider next one. Again, this difference is 1, so 0, 1, 2, 3, or 0, 1, 2, 1. Now, range here in this case is 2, in this case is 3. So again, this is bad. 0, 1, 2, 1 is good. So you can also shift this. You can say 1, 2, 3, 2. It is this. Let's check last input. Again, in this part, we can say A1. We have 4 elements, A1, A2, A3, A4. And the range here is 1. Range here is 1. Range here is 2. Range here is 0. Range here is 2. And range here is 2. Okay, again, like previous cases, first one 0, second one 1. The difference, next one 0, it's 1. Next one, this is 2. So you can say this one is 3. This one is plus 2 minus 2, negative 1. Now the range here is 2. Here it's 2. Here the range is 3. So 0, 1, 1, negative 1. You can shift all elements here. You can say 1, 2, 2, 0. Okay, it will be this. Now let me explain completely how to solve this problem. Okay, let me explain for you how we can solve this one. For example, our numbers are A1, A2, A3 to AN. And this one is R1, 2. This one is R1, 3, and like this. They range from AI to AJ. We define it as Rij. Now, I always consider, and the problem says it is guaranteed that there is a good sequence. A1, I consider A1 is 0, and A2 is R1, 2. Okay? Now we have this. So, the first two things are okay, and without loss of generality, we can say there is a unique way, because if we don't consider shifting or negating, so 0 or 1, 2. Now suppose that we've created, for example, A1, A2 to A, for example, M minus 1. Okay, now I want to see all of them are okay. Now we want to see how we can define AM. So let me tell you how we will define R3. Okay, R3 is better. A3 is better too. The idea, let me tell you here, it will be idea 8. Concerning small examples, so much useful and helpful both in USACO and USAM. Small examples also in AMC, AME, and IM. So A10, A2, R12, A3. I say here the difference is what? R13. So it is what? It is A1 plus R1, R23, because we know this difference is R23. So we know A2 is what? So A3 can be A1 plus R23 or A1 minus R23. Now I want to prove one of them works, and I want to consider different cases, okay? So, if R23, let's consider cases. If R23 is 0, then A3 will be unique and has to be A1, okay? And because it is guaranteed, so this A3 works. It is guaranteed that there is a good sequence and A3 unique, so this one works. Second case. So we can consider this case. In this case, R23 is at least 1. So we have two answers. And now I want to prove only one of them works. Why? At first, I say if these two things are equal, A1, A2. So 2, 1. If A1 equals A2 equals 0, then it is for the case when R12 is 0. So it is 0, it is 0. Next one, R23 or negative R23, both of them are similar because you can negate all values. So you can say, okay, A3 is R23 and you can consider it is good and finished. Case 2, 2. Suppose A1 is not A2. Now, we have two cases. Again, without loss of generality, you will see they are same. Suppose A1 is less than A2. Okay, so A1 is here, A2 is here, and again, without loss of generality, we can consider also R23 positive. You will see they are same. I'm sorry. R23 is always greater than equal 0 because the problem says maximum minus min. So A2 plus R23 will be something here. A2 minus R23 will be here or here. Will be, for example, this part or this part. Okay, one of these two things. Or we can say here or here. It's not important. A2 minus R23. Now, if we consider range of A1, A2, A3, it is R13 and it is constant in the beginning of the problem. So in this case, it is this one. In this case, R13 will be what? It's A2 minus A2 plus R23 minus A1. In this case, R13 is what? Absolute value of this difference. Okay, so it will be A2 minus R23 minus A. And I want to say, obviously, this one is less than this one. Okay, because they are different, so one of them is good because it is guaranteed that there is a good sequence. One of them is good. I should only prove that these two values are different. Let me tell you, let's use contradiction. Suppose A2 plus R23 minus A1 equals this one. So I consider two cases. Case one, if this one is greater than this one, it will be A2 minus R23 minus A1 if this one is greater than equal. Next case, R23 minus A1 if this one is greater, means, for example, it is this value. It is A1 minus A2 plus R23. So for this case, A2, A2, A1, A1 will be cancelled. R23 will be 0. That's a contradiction because we said it's greater than equal 1. In this case, you can say what? You can say R23 we can cancel and A1 equals A2. Because 2A2 equals A1, so A2 equals A1. Again, contradiction because we said A1 is not A2. So always we will see when you place A3, we have two options. A2 plus R23 or A2 minus R23, and always one of them is good in this case. Okay. Now we can generalize this idea. How? We can say, okay, suppose we have A1, A2 to AM minus 1, and all of them are okay. Now when we want to consider AM, again, you say if this one 0, if this one greater than or equal 1, if this. So you say if this one, we call it Rm minus 1 and M. If Rn case 1, if Rm minus 1 and M equal to 0, then Am equals Am minus 1 and finished. Case 2, if they are not equal, so Rm minus 1 means this one at least 1. Now I want to say this one is plus minus, so Am, we can say is Am minus 1 plus minus Rm minus 1M. I want to say one of them is good, but for which case? If all of them are not equal. Okay, so I divide to two cases. If A1 equals A2 equals to, if all previous elements are equal, then they should be 0 because A1 is 0. So here you place 0, 0, 0, 0. And then last one you place Rm minus 1 M for AM. And it's not important to place plus or minus because you can negate all elements. Exactly like here, like a small example here that we set this part. Case 2-2 is when all of them are not equal. Means, for example, AM minus 1 equals to AR plus 1. Consider first element that they are not equal. For example, AS. And now I say, okay, AM is AM minus 1 plus RM minus 1M and AM, or I want to say exactly one of them is good. Minus RM minus 1 M. I should consider what up to S means these elements. It is related to what are S and M. I want to say in this case, and in this case, RSM will be different. So one of them equals, RSM means the maximum minus minimum. If you place this one and this one, it will be different, but RSM is constant. In the beginning of the problem, from input, we get RSM, so one of them only is useful. One of them can be equal to AM because it is guaranteed. And why I say none of them is not possible, because it is guaranteed that there is at least one good sequence. The only thing that here I should explain is that one of them is good. Why? Because if both of them be good, then we should check both of them because, for example, in future, maybe, for example, one of them works. I want to say exactly one of them is good. So let's see. Here we have AS and AM. Again, without loss of generality, like here that I set A1 without loss of generality, A1 less than A2. Without loss of generality, suppose AS, for example. Now in that case, I said AS is less than AM minus 1 or A1 less than A2. Now here I consider this one to see that both of them are similar. So AS is here. AM minus 1 is here in this range. We have three values, AS, AM minus 1. Now AM, all of them here are equal. Next one is what? Next one is AM minus 1 plus RM minus 1M and or AM minus 1 plus minus Rm minus 1m. Now here the range will be from AS to this part. And for this value, it is the difference of these two elements, okay? I want to say they are not equal, so one of them can be equal to RSM. Why? Because this one, here I consider two cases. In case 221, suppose AS is greater than AM minus 1 plus Rm minus 1m. In case 222, suppose that AS are greater than or equal. Here AS is smaller than AM minus 1 plus RM minus 1. Now the difference here is what? AS minus AM minus 1 plus RM minus 1m. And the difference here is what? Because AS is greater than or equal to that, AS minus AM minus 1 minus RM minus 1m. And AS will be cancelled. AM minus 1 will be cancelled. So if we take to our left hand side, 2RM minus 1m is 0. So Rm minus 1m is 0. Contradiction because we said suppose that it is at least 1 here. We've considered the case that is 0. This one is what? Again, you say this difference, AS minus AM minus 1 plus Rm minus 1m equals the difference of these two things. This minus this. AM minus 1 plus Rm minus 1m minus AS. Now we can cancel these two elements. So if we take these to left hand side, these to right hand side, 2AS equals 2AM minus 1. So we can conclude AS equals AM minus 1. What we said, AS is not equal to AM minus 1, is greater than this. So it's contradiction. So we've proved always there is a unique sequence. There is a unique element for AM. You can continue like this to find all elements. Now let me show you the code. Okay, now the code is this. You can, let me move to this part here. Let me move it. In this part, we get input, and then I say if n is 1, 0, if n is 2, 0, or 0, 1, 0 bases. Then output of 0 is this, output of 1 is this, then out. In each step, we update minimum and maximum of the length. So when it is 1 means up to 1. And here into all 0, it is for the case that we've considered if all of them be 0, all of them equal. Then from I2, you say, okay, the distance is this, the difference, the range Ri minus 1i. So Ai is, or out I is plus minus d. This is if d0 is this, if all 0 it is this, exactly like the thing we said. Then for next case, I said consider it is plus d, then update minimum and maximum and check this. If it was 0, then consider minus d, so plus d. If plus d doesn't work, minus d works because the problem says it is guaranteed that there is a good sequence, then update minimum and maximum. And if, for example, an element is not 0, then all 0 will be 0. Then cout output. Okay, and here it is update min max code function, and this one is check function. If you had any question about this, as I said, or wanted to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Okay, now let me tell you a problem that is related to both math and informatics. It is what? This is, suppose we have this sequence. It is 1, 2 to 10, and we can color some elements black or white, and we shouldn't have, there is no two adjacent blacks. Adjacent means common edge. Common edge. There is no two adjacent blacks. How many ways are there? Ways are there. For example, like what? If we have one column, you can color like this, color like this, or whites. Whites can be adjacent, but blacks cannot be adjacent, so 3 cases. For 2, you say, okay, 1 case when all of them whites, 4 cases for this, 2 cases for this, so it will be 7. Okay. Now calculate 10 for 10. It's what? Solve this problem and comment your answers right below this video. And if you had any question, as I said before, feel free to send message to my WhatsApp number in the description. Okay, thanks for watching this video. Bye.